Welcome, my amazing geometry students. This is Ms. Ozanich, and I wanted to go over a couple of example problems with you guys to help you out with your assignment that you have this week. That has to do with angle and segment addition, and just some things you're going to see, and hopefully these examples will help you to be successful as you work through your practice this week. And we'll work on them in class a little bit too. Okay, so we've talked about the idea of a midpoint, and that your midpoint is, just like it sounds, the middle point. And right here you see a picture in our first example of K being the midpoint of the line segment JL. So if it's in the middle, hopefully it makes sense that this half must be the same as this half. And these little hash marks in geometry mean that the lines segments are congruent, which means that they are also equal. Okay? So we're going to take this information and see if we can't answer the question around this scenario, which is to find the length of JL. Well, JL is the entire length, right? So we want to find that entire length from J to L, the line segment. It tells us that JK is 5x plus 1. So I'm going to just write that right here, 5x plus 1. And it tells us that from K to L is 7x minus 3. 7x minus 3. Okay, so if we are doing segment addition, what we would do is we would add these two chunks together to be equal to maybe something we know about the length of JL. But here we don't know anything about JL, so we're going to have to use a different strategy. And that strategy we can use, because this is a midpoint, is to set these two congruent segments equal to each other. So we're going to set the 5x plus 1 equal to the 7x minus 3. We're going to do some algebra on this equation. I'm going to subtract 5x from both sides. I'm going to be left with 1 is equal to 2x minus 3. I'm going to add 3 to both sides and divide by 2, and I get x is equal to 2. I apologize for skipping steps through there. Hopefully you guys were able to follow that okay. We just added 3 here and added 3 here, and then divided by 2 at the end. Okay. So x equals 2 is not the answer to my question. It helps us to answer the question, but it's not all we need to know. We want to find the length from J to L. So we can take that x equals 2 and we can actually plug it back in everywhere we see an x in these two equations, right here and right here, and we'll go ahead and change that to 2 as well. Okay, so we have 10 plus 1, which is 11, plus 14 minus 3, which should also be 11 if that's the midpoint, and in fact it is. So together the measurement for JL is 22. So you'd say segment JL equals 22. Sometimes when you're working on problems like this, it will ask you for the x value, but then it will also ask you to analyze lengths of segments. Okay? So just be on the lookout for that. They might even ask you, what is the length of KL? And if you wanted to know the length of KL, okay, that would just be from K to L. And we know, because we plugged that value of 2 just into that portion, that the value of K to L would be 11. So be mindful of what the question is asking and make sure you answer all parts. All right, moving on. Let's take a look at this question right here, this idea of a supplementary angle. All right. We know that supplementary angles add up to 180 degrees, right? 180 degrees are supplementary, 90 degrees are complementary. So we're going to have one angle that's shaped probably like this, coming together with another angle to form a straight angle 180 degrees. It says that the measure of angle 1 is 3 times greater, so 3 times greater means we're going to be multiplying by 3, than the measure of the other angle. All right, well, let's make the other angle m degrees. We'll call that the measure of angle 2. And if this is 3 times greater than angle m, then the measurement here must be 3m. Now here's where it gets a little tricky. Together, these two angles are supplementary. So together, these two angles add up to 180 degrees. So we have m plus 3m is equal to 180. We add those two together, then we are going to get 4m is equal to 180 degrees. And if we keep going with that, what should be our next step? Hopefully you're thinking divide by 4. Divide by 4, excellent. So we have an m value that is equal to 45 degrees. Okay. Now, again, that answers part of our question. What is the measure of each angle? Well, it looks like the measurement of angle 1 is going to be 3 times 45 degrees, or 135. And the measure of angle 2, which is the other angle, is going to be 45 degrees. Okay? And again, we'll continue to practice with these ideas of supplementary and complementary angles and adding them together to solve problems. One more example for you, and then we'll be done. Let's look at this last one right here. And part of what you need to do with information that is given for a diagram is I always label things as I come across the information. And you're going to have to read carefully so that we can answer this final question. Okay, so let's read carefully and label some things. This means the measure of angle SRQ, so SRQ, is equal to 100 degrees. So I'm just going to go ahead and write that 100 degrees out here. We're going to use some different colors on this problem just to make things a little easier. The measure of angle URQ is 24x plus 2. So you see how I've labeled that angle 24x plus 2. It also says that the measure of SRU is 24x plus 2. Oh, okay, so these must be exactly the same in terms of their measurement. Interesting. Okay, so if these are exactly the same in terms of their measurement and the two of them added together is equal to 100, we could tackle this in a couple different ways. We could go this route where we add together 24x plus 2 plus the 24x plus 2, that is my purple angle here, to equal my total, which is going to be 100 degrees. Okay, that's one way we could do the problem. We could also notice that because these are exactly the same and the entire measurement of my angle is 100, that probably this is a bisector, an angle bisector, which means it cuts it exactly in half. And I could also go about solving the problem by setting my 24x plus 2, just one of these angles, equal to 50. All right, and that would be 50 because it would be half of 100. Okay, so let's see if both of these work out. Let's do a little math here together. So I'm going to add my x's. That's going to give me what? 48x plus 4 is equal to, what do we have? 100. And then if we subtract 4 from both sides, we get 48x is equal to 96. If we divide by 48, we do some good mental math here. We get x is equal to 2. Let's see if the same thing happens on this side. Subtract 2, subtract 2. I end up with 24x equals 48. And as I divide by 24 on both sides, I get x is equal to 2, and they're the same. So that worked out great. Now again, watch out, guys, because even though you have this great answer of x is equal to 2, you still have to answer this question. Find angle SRU. Where is that? Let's highlight it so we can see it. From S down to R, out to U. There it is. So what we're going to do is we're going to take the expression 24x plus 2 that I know matches with that angle, and I'm going to take this good value of x that you just found, and I'm going to plug it in there and simplify. So you might have guessed already, just based on the information, that 50 was going to be the measure of angle SRU. And some of you guys might be thinking, well, Miss O, we didn't really have to do all that work, since once I know 24x plus 2 and 24x plus 2 are the same, I can just take my 100 and cut it in half and get my answer of 50. Yes, you can do it that way as well. Okay? I wanted you guys to see some algebra around that example. Hopefully that will help you in future problems that you work on dealing with angle addition. All right, guys, have a great day.